For this unit, we'll be looking into probability. Probability. You might have heard the term tossed around in everyday language, so let's use a very simple example to give it a formal definition. Imagine tossing a coin. It may land on heads or tails, and the chances of landing on both heads or tail are equally likely. So we say there's a 50-50 chance of landing on either one of them. Think about the statement, 50-50 chance. It is saying that there's half or 1/2 chance of landing on either side. Let's say head for this case. The one part represents a single desired outcome, which is landing on heads, and the second part requires all possible outcomes, which are either landing in heads or landing in tails. With this thought in mind, we can create a formula for the probability, which is the probability of an event happening is equal to the number of desired outcomes by the number of all possible outcomes. Next, we use something called a tree diagram to visualize all the possible outcomes of an experiment. It is generally used when the experiment is repeated 2 or more times. Going back to the example of coin tossing earlier, it would look something like this. There's a branch for each outcome, and this part tells us the probability of the event taking place. So what would happen if we toss the coin another time? Well, the tree diagram would branch off to the second round from each of the branches of the first round. We now have 4 possible outcomes from this entire 2-round long experiment. Here's how to interpret them from the tree diagram. For example, if we go through the head part of the branch for the first round and then to the tail part for the second round, this is basically saying we got heads for the first try and tails for the second try. So for the outcomes from the scenarios described would be heads first, tails second. If we use the same method for the rest of the branches, we will get something like this. Feel free to pause the video and go through each of the branches one by one. In addition to this, since we know that there are equal chances of landing heads or tails, all 4 outcomes are equally likely and the probability will be 1/4 each, since there are 4 possible outcomes and 1 favorable outcome for a single event. Now let's look into the first round. What would be the probability of the coin landing either heads or tails? The answer is obvious. It will be 1 or 100%. Because there are only 2 possible outcomes, you always land either heads or tails. You don't land on heads and tails at the same time. Because these 2 events cannot happen at the same time, they are said to be mutually exclusive. Now the probability of landing on these 2 events is half each, and the probability of landing on either of those 2 is 1. We can see that the 2 probabilities were added together to give 1. This is the addition law of probability taking place. It states that the probability of either one of the mutually exclusive events A and B is happening. The probability of A happening plus the probability of B happening. Next, we know that the probability of getting heads first and tails second is 1/4. We can see that the 2 probabilities were multiplied to give 1/4. This is the multiplication law of probability. It states that the probability of getting 2 outcomes A and B on separate rounds is the probability of A multiplied by the probability of B. For a general rule of thumb, if the question wants the probability of A or B, you will have to add them. If it wants the probability of A and B, you will have to multiply them. In the next video, we will look over how to consider other factors affecting probability.